Today we're going to learn about hypothesis testing. To learn this, first we're going to learn a few topics that are going to be helpful to solve hypothesis testing. First, we're going to learn how to make the z-tests.
To find the critical C of a number. In this case, we just need the significance level. Or the alpha. With this alpha, example, 0.025, what you need to look in this graph is in the heart of the graph, that number. Finding that number, the two numbers from the top and from the side, in this case being 0.6 and negative 1.9, these two numbers are gonna give you a critical C. So your critical C in this case it's 1.96.
Now we're gonna apply the previous topic in the following problem. In Julio Villalobos Ranch, there are hundreds of walnuts trees. In average, each tree produces 50 kilograms of nuts a year, with a standard deviation of 9 kilograms. Julio claims that if he applies fertilizers on each tree, they will produce more nuts a year. Julio wanted to test the hypothesis by applying fertilizer to 20 trees. When they tested it, they realized each tree produced 54 kilograms of nuts on average a year. Following a normal distribution, use a significance level of 5% of Julio's hypothesis.
The first step is to find the claim. Julio claims that using a fertilizer will increase the amount of nuts the tree produces a year. So he tested it and it came up that using the fertilizer, 54 kilograms of nuts a year, and without the fertilizer, the tree produces only 50 kilograms of nuts a year. So we write the claim saying that the mu is more than 50 kilograms of nuts a year. And we have two different types of hypotheses. This is the first step. The second step is the two different types of hypotheses. We have the null hypothesis called HO, that this is the null hypothesis that will prove your hypothesis wrong. And then we have the HA, that is the alternative hypothesis. So the null hypothesis has symbols like equals, less than or equal, or more than or equal. And the alternative hypothesis has symbols like not equal to, less than, or more than. Because we're saying that this is our hypothesis, our alternative hypothesis is mu is more than 50. And if we prove it wrong, we will say the opposite, saying that the mu is less than or equal than 50. This is what we have to prove.
The next step is to collect all the information the problem gives us. So we know that the alternative hypothesis is mu greater than 50. Then we know that the standard deviation is 9. That the n, that means sample number, is 35. That the mean is 54. And the alpha is 0.05. Then, following a normal distribution and knowing that the alternative hypothesis is mu greater than 50, we are gonna calculate the C critical, that we put here the 0.05, and this is the shaded part because we know that the mu is greater than 50. So this is the right tail, and the rejection. And the not shaded part is the acceptance.
In step 5, we're gonna find the C critical. As we learned before, to find the C critical, we're gonna use the significance level, in this case the alpha, and we're gonna look for the 0.05 in the core of this chart, to find the critical C. In this case, our C critical is 1.645, and it lies right here, 645. And in step number 6, we're gonna find the C calculated, which the formula is x bar, which is the mean of the sample, minus the mean, the mu, divided by the sigma over the sample square root. So we have 54 minus 50 divided by 9 over square root of 35, which gives us a C calculative of 1.99. This number in the chart, being the 0, these positive numbers, rise right here, 1.99. So it's on the rejection area of our graph.
For the step number 7, we're going to choose if we're going to reject the null or accept the null. We're going to come back here and we're going to see that the C critical ended up in the rejection area. This means that we are rejecting the null hypothesis, because the null hypothesis is always the one that we're talking about. Either we reject it or accept it. And here, since the number was in the rejection area, we are rejecting the null hypothesis. And finally, for step number 8, here, since every time you reject something, it means you are accepting the other one. So here in this problem, since we are rejecting the null hypothesis, that means we are accepting the alternative hypothesis, which is Julio's claim and our claim. See, it's the same. So we're going to write our conclusion in words. There is sufficient evidence at the level of alpha being 5% to support the claim that on Julio's branch, fertilizers cause walnut trees to produce more nuts than average.
Thank you. That was all for today, and it was an explanation of how to use the hypothesis testing.